Just imagine a completely self-sufficient, environmentally friendly solution enabling you to heat your home that delivers hot water to every tap and even heats a swimming pool by harnessing the power of nature, and all in one package. The ultimate heating solution, HeekSeeker Supreme. The HeekSeeker Supreme system provides massive savings in running costs and slashes greenhouse emissions. At the heart of the system is one of the biggest breakthroughs in technology seen in many years, the revolutionary award-winning evacuated tube solar collection system. A correctly designed and installed system has the power to heat your house, your pool, and even supply your hot water year-round, all employing the unbridled power that is the sun. It's free, it's unlimited, and it will be available for many generations to come.
Before we see how the evacuated tube solar collection system works, let's take a look at what hydronic heating is.
Now, there's lots of ways that people heat their homes. There's conventionally heated forced air systems that blow around a lot of stuff you really don't want to think about, especially if you suffer from asthma or hay fever. There's the undeniable beauty of an open fireplace, where 90% of the heat goes straight up the chimney, not to mention the greenhouse contribution or the safety implications for small children. Then there's the wood-burning space heater with the same greenhouse and kid-safe issues as an open fire. A lot of people are also installing split-system reverse cycle air conditioning systems, but the running costs are way too high. All of these solutions have one thing in common. None of them will heat a room evenly. One spot will be comfortable, while another area in the room will be a little too cool. Also, especially in the case of ducted air systems, they generally deliver the highest air temperatures near the ceiling. A radiant floor and panel heating system delivers the most effective corner-to-corner warmth that is available, all while being very safe. That's why hospitals around the world have relied on the passive power of radiant heating for years. A constant, reliable temperature that can be adjusted room by room for individual needs, all without fan-forced air spreading dust and contaminants from ward to ward. Now, there's two radiant heating systems. One is heated by electricity and one is known as hydronic, which employs warm water. Hydronic is found in the majority of hospitals, schools and public buildings because it's about 1/3 of the cost to run and it's virtually maintenance-free. Once the hydronic system is installed, there's no more expense, unlike ducted forced air systems that require the ducts to be professionally cleaned at least once a year. You'll be surprised just how much this servicing will cost over a 10-year period. Let's take a closer look at how hydronic heating works.
A small amount of warm water, heated to around 35 degrees Celsius, is silently pumped through special tubes that are laid just below the floor, delivering even, comfortable heat where you want it, and you can control each room's temperature with the twist of a thermostat. This is very different from a traditional ducted system that blows most of the heat up to the ceiling, and there is only one set temperature for the whole house. Radiator panels are wall-mounted in rooms where floor heating is not practical, delivering the same safe, controllable, corner-to-corner comfort that you will get used to very quickly. Let's head up to the roof and see just what makes all the difference, the evacuated tubes. Now, because these tubes are nearly 2 meters long, let's shrink one down so you can see how they work. It starts with the ultimate collection device. A double-walled vacuum tube, much like a thermos, rather than a flat panel. Your first question will be, why? What's the difference? Well, it really is quite simple. The two most important principles of high efficiency are to maximize solar heat gain and minimize heat loss. And an evacuated glass tube beats a flat panel hands down every time. Here's why. For starters, the double-walled vacuum tubes are created from borosilicate glass, which was first developed by German glassmaker Otto Schott in the late 19th century. It has a very low thermal expansion coefficient, in fact about 1/3 that of ordinary glass. What this means is the tubes are made from a glass that can handle the stresses caused by extreme temperature differences, making them more resistant to breaking, You might be surprised to know this remarkable glass is found in almost every kitchen in Australia. It's called Pyrex.
So naturally, borosilicate is a material of choice for evacuated tube solar thermal technology due to its high strength and heat resistance. And let's face it, you're putting it on your roof, and everywhere gets hail occasionally.
Now, inside the inner tube, there is also this amazing coating which absorbs heat. And because there is a vacuum between the inner and outer tube, this just about eliminates convective heat loss. And this is where all the energy from the sun starts to go to work. The sun's energy that is absorbed by the tubes is transferred to your water by a special food-grade liquid that, once heated, expands and turns to gas, much like steam from a heated kettle, and rises at extremely high temperatures to the tips of the pipes, which are inserted into a heat transfer manifold located on your roof. As the water in the manifold is heated, the gas in the tube cools and returns to a liquid, to start its journey up the tube again once the sun has done its job and turned it back to heated gas.
The design of your solar hydronic system requires careful consideration. Supreme Heating's consultants will need to enter accurate details of your home's construction into a computer to calculate the energy inputs required for effective heating. A solar hydronic system requires a much larger array of evacuated tubes than, say, a typical solar hot water installation, simply because of the additional energy load placed on the whole system. It also makes sense that for optimal solar input, the evacuated tube panel should be installed on a north-facing roof, and the ancillary equipment, like the storage tank, should be installed as close to the solar panels as possible to ensure that heat losses are kept to a minimum.
Now, flat panel solar collectors can produce a similar heat output to evacuated tube collectors, but generally only during warm, still, sunny conditions, and the sun has to be at 90 degrees, directly above the panel, for 100% efficiency. Whereas an evacuated tube collector is round, it doesn't need to be at right angles to the sun to deliver 100% efficiency. In fact, when averaged over an entire year, evacuated tube collectors can be up to 80% more efficient than flat plate panel collectors. Okay, that's the basics of how a heat pipe collector works. The only decision you'll ever need to make is whether you want your home's hydronic heating or swimming pool to benefit from the hot water you've generated. This is done via a simple press of a button on your solar controller, which still prioritizes your hot water system, but when the hot water service has reached its preset temperature, diverts the heat generated on the roof to the pool via a separate heat exchanger. If you've set the controller to hydronic to heat your home, the hot water from the collectors on the roof bypasses the pool's heat exchanger and is pumped through a heat exchange coil within a super-insulated storage tank. And the heated water in the tank is ready for use around your home.